Section 8.7, Complex Numbers. So now we're going to get into i's. If you haven't seen I before, I is known as the imaginary unit. When you talk about the imaginary unit, we have to understand that under a square root, say for example, square root of -9, it's not a real number. I can't multiply the same number twice and get a -9. So it is considered an imaginary number. By definition, the square root of -1 is I. If we square both sides, square the square root, the square and the square root cancel out, and I squared is I squared. So if the square and the square root cancel out, then I get that this just turns out to be a -1. So I squared is -1. So just a little bit of background knowledge. When you first started learning numbers, we were learning natural numbers. When we learned to count, 1, 2, 3, 4, and so forth. From there, we added just one number, we added the 0, and those were considered whole numbers. Whole numbers started with 0, and then 1, 2, 3, 4, and so forth. From there, we added negatives, and that's where we got our integers. So our integers were like -3, -2, -1, 0, 1, 2, 3. After that is when we added rationals. And what do we mean by rationals? Everything in those inside boxes plus fractions and decimals that repeated or ended. So fractions and decimals that repeated or ended. Now, we also have a kind of a cylinder or box by itself, and those are called the irrational numbers. And the irrational numbers were like square root of 2, square root of 3, pi. Later on, you'll know something called e when you take college algebra. But those are the irrational numbers. Those numbers never end nor never repeat. In your calculator, it looks like they stop, but they don't. So we have been dealing with some of the irrational numbers when we have dealt with our square roots. Putting those two boxes together, all of the rationals and the irrationals, we call those the real number system. And that's pretty much where we've dealt with up till now. We've had either rational numbers or irrational numbers. Well, now what we're going to add is a box all by itself, and it's called the imaginary numbers. The imaginary numbers are like I, square root of -6, square root of -25, when you have a negative under the square root. And putting these boxes together, all the reals and the imaginaries together, that is considered our complex number system. And every number can be written as a complex number A plus BI. The A comes from the real part, the BI comes from the imaginary part. So 5 is a complex number because you could write it as 5 plus 0i. So I just wanted you to kind of see where you started with numbers and where we've grown and what we're adding to, as of today, the imaginary numbers. So let's begin with simplifying. 1 is the square root of -81. I'm going to kind of show you all the steps in between. You can certainly skip some steps. But the square root of -81 is the square root of -1 times 81. Breaking those up into each its own radical, we get the square root of -1 times the square root of 81. We know the square root of -1 is I. By definition, I is the square root of -1. And we know that the square root of 81 is 9. So my answer turned out to be 9i. For number 2, the square root of -7. Well, that's like the square root of -1 times 7. So we get the square root of -1 times the square root of 7. The square root of -1 is I, square root of 7 is irrational, we cannot simplify it, so we get I square root of 7. The I really should be at the end, but not underneath. So I kind of leave a little bit of space to show you that it is multiplication. The I, if you want to leave it in front for now, that's fine, but it really should go at the end. Just don't put it under the radical, because it is a radical. So number 3, square root of -32. Well, we do see it as the square root of -1 times the square root of 32. Square root of -1 is I. And what's the square root of 32? Well, we have 32 is 16 times 2, and we know the square root of 16 is 4. So we end up with 4i square root of 2. Again, if you want to write the I at the end, that's great, but just make sure you don't put it under the radical. So the answer would be 4 square root of 2i. On number 4, we have the square root of negative 80. Well, that's the square root of negative 1 times 80 under the radical. So the square root of negative 1 times the square root of 80. The square root of negative 1 is I. Let's do the factor tree for 80. Well, 80 would be 8 times 10, and 10 is 5 and 2. 8's 4 and 2, and 4 is 2 and 2. So I actually have two pairs of 2's. So a 2 comes out, another 2 comes out, and I was already out there, and the 5 is left underneath. So I end up with 4I square root of 5. Again, putting the I at the end is a little bit better, but I will accept both answers. Just make sure the I is not under the radical. So to add or subtract complex numbers, all you got to do is add or subtract the corresponding real parts and the corresponding imaginary parts. So it's like just putting the like terms together. So why do they have the parentheses? Well, for number 1, it says 5 minus 3i in parentheses plus parentheses 4 minus 5i, and they told us to add or subtract. The reason why they have the parentheses is to show that in a sense, this is the first complex number, a plus bi, and this is the second complex number, a plus bi. But if what you notice is in between is a plus sign, we don't need to distribute anything but a plus sign, which doesn't change anything. So we end up dropping off the parentheses, so 5 minus 3i. If we distribute a plus sign, we still get plus 4 minus 5i. Then we'll combine the real parts and the imaginary parts. So 5 plus 4 gives me 9, and I have a negative 3i minus 5i, which is a negative 8i. So my answer is 9 minus 8i. For number 2, again, we don't really need those first parentheses. They're just saying here's the first complex number. So we'll drop off those parentheses. But be careful, with the second parentheses we have to distribute. So we end up with a plus 1 minus 3i. Combining the real parts, 8 plus 1, I end up with a 9. And we have a negative 6i and a negative 3i, which gives me a negative 9i. So my answer is 9 minus 9i. So to multiply complex numbers, you multiply like usual. But remember that I times I is I squared, and we know that I squared is negative 1. Just like x times x is x squared, I times I is I squared. But we know that we can substitute in for what I squared is equal to. So multiply. Number 1, 4i times 7i. We'll multiply 4 times 7, I get 28, and I times I is I squared. This is multiplication, and we know I squared is negative 1, so 28 times a negative 1 is negative 28. Number 2, negative 7i times 5 minus 9i. Well, we need to distribute, so negative 7i times 5 is negative 35i. Negative times a negative is a positive, 7 times 9 is 63, and I times I is I squared. We know what I squared is negative 1. Don't substitute anything in for I, but we do know I squared is negative 1. So negative 1 times 63 is a negative 63. I'll put the real part first and the imaginary part second. So we get negative 63 minus 35i. Number 3, parentheses 5 minus 2i times parentheses 4 plus I. It's a binomial times a binomial, so we definitely need to distribute. 5 times 4 is 20. Outer 5 times I is 5i, so plus 5i. Distributing on the negative 2i times 4 is a negative 8i, and negative 2i times I is a negative 2i squared. Putting like terms together, we have a 5i minus 8i, so that's going to give me a negative 3i, so minus 3i, minus 2 times I squared is negative 1. So we end up with 20 minus 3i, and a negative 2 times a negative 1 is a positive 2. Now these like terms can go together, so I end up with 22 minus 3i. On number 4, we have 8 minus 3i quantity squared. We cannot square pieces because there's a minus sign in between. We have to write that binomial twice and FOIL it out. We don't change it into a conjugate, we just write the same binomial twice and FOIL it out. 8 times 8 is 64. Outer gives me a negative 24i. Inner gives me a negative 24i. And negative 3 times negative 3 is a positive 9. I times I is I squared. So putting like terms together, those do not cancel each other out. They actually combine to make a negative 48i, and I have plus 9, and I squared is negative 1. So you end up with 64 minus 48i, and 9 times negative 1 is negative 9. So then we'll need to combine the 64 minus 9, which gives me a 55 minus 48i. Try putting the real part first and the imaginary part always second. Now let's talk about dividing. To divide complex numbers, we must think about rationalizing. We must rationalize the denominator. Why? Because I is a square root. It's a square root of negative 1. So when you see an I in the denominator, that's like having a square root left over in the denominator, which is not in simplest form. So divide and write in standard form. Number 1, 6 divided by 7i. Well, we can't reduce 6 over 7, so the dividing really is done, but we need to get rid of the I. So remember what I squared is. I squared is negative 1. So if we multiply top and bottom by I, that's like multiplying by just a fun kind of 1, we'll end up with an I squared, so therefore we can substitute in. So when we have 6 divided by 7i, it kind of looks like we're done. But remember, I is a radical. So we need to multiply top and bottom by I, which will help get rid of the radical in the denominator. So 6 times I is 6i, and 7i times I is 7i squared. Again, I squared is negative 1. So we get 6i divided by 7 times negative 1. And so we end up with 6i divided by negative 7. Be careful not to leave the negative in the denominator. We want to put the negative out in front or on top. I'll put it on top, so negative 6i all over 7. Number 2, we have 4 plus I divided by 4i. We cannot cancel the 4's. One has a 4 plus I, the other one does have multiplication, but they cannot cancel. So what's the thing we need to get rid of is the I in the denominator. So we need to multiply top and bottom by I. We definitely need to distribute, so I'm going to put the first numerator in parentheses. So when I distribute the I on top, 4 times I is 4i, and I times I is I squared. So we get 4i plus I squared on top. On bottom we have the 4, and I times I is I squared. We'll substitute in for we know what I squared is. I squared is a negative 1. And so we have 4i plus a negative 1, and on the denominator, 4 times a negative 1. So on top, I'm just going to flip those around, so I get a negative 1 plus 4i, and then the denominator, we end up with a negative 4. We're not allowed to leave a negative in the denominator, so when I bring it up, I actually have to change both of those signs. So negative divided by negative is a positive, and then a negative 4i all over positive 4. One last thing they want you to do is separate the real part and the imaginary part. The real part is 1 over 4, minus the imaginary part is 4i over 4. Now we can reduce the 4i over 4. So my final answer is 1/4 minus I. These two answers are the same. One is written in complex form, which is where you should be going to. So make sure you can separate the real part and the imaginary part over their own denominator and simplify if possible. So the final answer should be 1 over 4 minus I. Now looking at 3 and 4, they're different than 1 and 2. 1 and 2 only had, in a sense, a monomial in the denominator. But on 3 and 4, we have a binomial. So what did we do in the previous section? To get rid of a radical in the denominator when we had a binomial, we multiplied by the conjugate. So the conjugate of 6 plus I is 6 minus I. And we did the same thing on top and bottom. So now we'll distribute on top. 5 times 6 is 30, and 5 times I is a negative 5i. In the denominator, 6 times 6 is 36. Because it's a conjugates, outer and inner are always going to cancel, so I won't show that. And I times negative I is negative I squared. So the numerator, we still have 30 minus 5i. And the denominator, we have 36 minus I squared is a negative 1. So that just turns out to be a 36 plus 1. So we end up with 30 minus 5i all over 37. Again, you need to separate the real part and the imaginary part. So the real part is 30 over 37 minus 5i over 37. If we could reduce either of those fractions, we would, but none of those can be simplified. Number 4. 1 plus 3i divided by 5 minus 2i. Again, we have a binomial on bottom, so what do we need to do is multiply by the conjugate, which is 5 plus 2i. Same thing, whatever we do to the bottom, we do to the top. Because they're binomials, we definitely need to put everything in parentheses so we can distribute. On the top, 1 times 5 is 5. 1 times 2i is plus 2i. Inner gives me a positive 15i. And last gives me a plus 6i squared. In the denominator, 5 times 5 is 25. Outer and inner will cancel each other out. Negative 2i times a positive 2i is a negative 4i squared. So now we'll plug in what we know for I squared, and we'll combine like terms. So on the top we have 5 plus 17i, and we have plus 6 times a negative 1, because I squared is negative 1. In the denominator we have 25 minus 4 times again a negative 1. So on top, 6 times a negative 1 is a negative 6, so 5 minus 6 is a negative 1, plus 17i, over negative 4 times negative 1 is a positive 4, and 25 plus 4 is 29. Again, separating it into the real part and the imaginary part, we get negative 1 over 29 plus 17i over 29.